Hello everybody, today I'm gonna show you Kmeans clustering using RStudio. As all of you are familiar with the word clustering, clustering is a broad set of technique for finding subgroup of observation within a given data set. That means you want observation in the same group to be similar, as well as you want observation in different groups to be dissimilar. So to do Kmeans clustering analysis, you have to load tdiverse, cluster, and factoextra packages in order to run Kmeans clustering analysis in your RStudio. So that to perform cluster analysis, also your data should be arranged or you should be prepared in the following way. You have to consider your rows as observation and columns as variable. And if you have any missing value in your data, you must be removed or estimated. And lastly, your data must be standardized or scaled so as to make variables comparable. And maybe this standardization consists of transforming of the variable in such a way that to have a mean 0 and standard deviation 1. So don't forget to run this package to in our studio, then also factoextra. Then our data we are going to use in this tutorial is USRS, which is found in RStudio, that contains statistics in arrest per 100,000 residents for assault, murder, and rape in United States of America for 50 states. And so let's check whether data is look like. So here is the data. Let's see, instead of looking the entire data frame, let's check the first 6 row. Then we have here Alabama, Alaska, Arizona, Arkansas, California, and Colorado, which are the states, and it is observation, while the column 1, the murder, assault, urban population, as well as rape, is the variable. So instead of writing USA arrests, it is better to assign this data into what? Into df. So run df here. After that, you have to remove any missing value. To do that, type this one, df. You can give any name. So any add-omit function is used to remove any missing value in your data. So write your data name is df. So I did in this way. And then also your data should be standardized so as to have mean 0 and standard deviation 1. So you have to use scale. You have to type scale and write your data. Then run it. After that, let me check it whether it is standardized or not by typing head and writing df or data name. So here is the Alabama, Alaska, Arizona, and as you see here it's 1.24. But if you compare the first one, somehow it's different number. So we standardize to make variables comparable. So let's go computing Kmeans clustering. To do that, we have to set, or we have to type this syntax. Kmeans is a function, def is our data, centers means clustering to two groups, and start is just initial, giving an initial, or it is sometimes R will try 25 different random starting assignments and then select the best result corresponding to the one with the lowest within the cluster variation. So to do this, you have to say n start is equal to 25. Most of the time R uses 1, but if you have a large data set and to have a good stable result, you have to set n start as a 25 or 50. So type this one and run it, and let's check it. It is structure, what look like the structure, and you can find the clusters, you can find the vectors, the scales, whatever you want. This means is total sum square, while here is the size is what the number of points in each cluster, that means 20 is 30, and also here within, that means vector within cluster sum square, and even also you have centers. Let's here, yeah, centers. So centers is a matrix of cluster centers. So by this way, even we can find here the cluster. Yeah, here is the cluster. So the cluster is the vector of integers at indicating the cluster to which each point is allocated. So by this way, you can see your structure for further detail. So let's back to our issue, and then you have to use this function and k2 value, then our data name is which is equal to def, or data name is def. So k2 means center is equal to 2, means it will divide it into two clusters, all observations, the first 25 initials. So let's run it here. Yeah, as you see here in the right side, it's divided into two clusters, but this is depend on your situation, on your just requirement. Then after, if you want just to proceed or to give more number of clusters, you have to do you maybe centers into 3, maybe centers into 4, and also centers into 5 to have a different clustering. So to do that, so because the number of clusters must be before as we start the algorithm, it is often advantageous to use several different values of k, and it helps us to examine the difference in the result. So we have to execute the same process as like we did in the k2. Let's arrange this k3, k4, k5. That means having our clusters maybe divided into 3, and also having 4 clusters and having 5 clusters. So let's run it together into one. But alternatively, we can use a standard pairwise scatter plot in order to illustrate the cluster compared to the original variable. So to see the original variable, you have to run this one. So here is the classification. Let me zoom it. Yeah. So this is the original classification. If you are interested in this way, or you can do in the previous one. So to have many clusters, so you have to run this one together. Yeah. So then after, to compare the plots, you have to type the plot 1 that contains the cluster 2, and the plot 2 that contain the cluster 3, plot 3, 4, and plot 4 cluster that contain 5. So by running, select this one and run it together, we will get some image. Yeah, so it's already entered here. Then the library you have to call grid extra to visualize the plots together in one way. So grid.arrange and the plot 1, plot 2, plot 3, plot 4. That means plot 1 that containing 2 cluster, plot 2 that containing 3 cluster, and 4 cluster, 5 cluster. So then type this one and run together. So it will give you some imagine this in the right side. Let me zoom it. Yeah. So this has help you to there is sorry, there is 2 cluster, and here is 3, here is 4, and here is 5 clustering. So although this visual assessment tell us whether that means tell us where true delineations occur between the clusters, but it doesn't tell us what the optimal number of cluster is. So to determine the optimal clustering, we need to use elbow method, gap statics method, as well as seal-out method. So we will see in the coming video. So if you have any question regarding to my tutorials, you can address me through my email, work.asfar@gmail.com, as well as you can also use YouTube channel box for providing your valuable comment. Thank you for watching and have a nice time. Goodbye.